Okay. Now, for it to be a true solution,
Hey.
hey,
Do you have a Caroline Hall and a Michaela Pettit?
I do.
Is it? I'm done. Okay.
That's all right. They probably appreciate the fact you disrupted.
You got to come back on her.
I guess I need to.
You got to come back with them.
Yeah, probably so. Okay, let's pay attention up here, please. Give me your attention up here. Is there water on back there somewhere? You wash your hands? Okay. All right. So, when we're talking about dissolving something, we're talking about dissolving particles that are a nanometer or smaller by other particles that are a nanometer or smaller. Okay? Dissolving involves particles that are a nanometer or smaller in size. Whatever kind of solvation is going on, those particles have to be that small. Okay? How small is a nanometer? How big is a millimeter?
Yeah.
All right, but let's think about that a minute. All right, how big is a millimeter?
1,000, right?
Okay, each of those little tiny marks right there, between each of those little marks, that's a millimeter. So what is it? It's maybe 3 times the thickness, maybe 2 times the thickness of my fingernail. Okay? Imagine cutting that into 1,000 pieces. Cutting that millimeter into 1,000 pieces. I don't know with what. Imagine how you do it. Listen, if you don't pay attention, you can't expect to understand. Okay? All right. Now imagine for a minute you cut that little millimeter into 1,000 pieces. That's not small enough yet. Take one of those pieces that you just cut it. You cut it into 1,000 pieces. Take one of those and cut it in another 1,000 pieces. You got a nanometer. That's right. It'd be way, way, way too small to see. Much, much, much too small to see. Even cutting this into 1,000 pieces, you couldn't see it. Okay? All right. So that's how small they have to be. What happens when they get a little bigger? All right. So solutions are the result of having particles that are a nanometer or smaller. The result of having particles that are a nanometer or smaller. Okay? If I have particles that are larger than a nanometer, between a nanometer and 1,000 nanometers. So I've dissolved something that's a little bit too big to be a solution. I might have dissolved it in something that has nanometer-sized particles, but the thing that's being dissolved, if you can't really call it dissolving, you've mixed it, and it is getting mixed up, broken up into particles that are between a nanometer and 1,000 nanometers, what we would in a solution call the solute. We don't call it that in this. But if the particles are between a nanometer and 1,000 nanometers, we no longer have a solution. Okay? That's called a colloid. Now, if the particles are larger than a nanometer, I mean 1,000 nanometers, larger than 1,000 nanometers, we no longer even have a colloid. Okay, if you can get the particles to stay dissolved for a short time, or not dissolved, mixed up for a short time, then you've got a suspension. You can get them to stay kind of mixed up for just a little while. You got a suspension. Yeah, those particles are larger than 1,000 nanometers. Okay? Now, if you can't get it to stay sort of mixed up a little bit, it's not even a suspension. Okay? Now, those are round numbers because sometimes there's some overlap, things happen. Okay? But that's generally considered to be the way it works. All right? So let's look at something that would give us an example of that. Chocolate milk. All right. What's in chocolate milk? So, but the chocolate is made of two different things.
Oh, that's sugary.
Okay, so we've got sugar, got cocoa. The syrup is made of sugar, cocoa, and water.
Flavoring.
So there's water. The milk is mostly water. So what's in the water that makes it milk? There's
Cocoa.
okay. There's all kinds of things dissolved in that water. There's lactic acid. There are milk sugars. Okay. There are proteins, but they're dissolved in there. It's true. And there is milk fat. Okay? This is what gives the milk its color. This is what gives the milk its color. Fat doesn't like water. Fat doesn't like water. Fat is nonpolar. Water is polar.
Why would you left over fat on bacon?
Well, let's don't get into that right this minute, okay? You're basically boiling out the oils when you cook bacon. Okay? Now listen. Shh. What is in all this stuff in chocolate milk? What's the solvent?
Solid. Sugar. Sugar is solid.
Water's the solvent.
Oh, you said solid. Cocoa said solid.
Okay? Is there anything that's actually dissolved in a chemical sense, dissolved in water from all of this? Sugar's dissolved. We just talked about that, didn't we? That makes it a solute. Okay? What about the milk fat?
This means dissolved.
It's not really dissolved. Listen, the milk fat is the particles of milk fat are too big to be a true solution. This then makes a colloid. And if you leave milk in the refrigerator, what happens to the cocoa part of it? It settles to the bottom, doesn't it? This is a suspension. Okay? So, chocolate milk is an example of all three categories. The sugar in water is a solution. The milk fat in water is a colloid, and the cocoa in water is a suspension. Okay? Okay, let's go back to the fact that milk fat doesn't like water. Anything that's nonpolar and doesn't like water, anything that's nonpolar and doesn't like water is called hydrophobic. Yeah, waterphobic. What?
When you freeze milk, like, is that just water, the ice part?
Mm-hmm.
So you can take that out and it makes it like that?
Can you separate the milk solids? I don't know if you can because the milk solids are kind of just suspended.
If you scrape the ice off of it and then you let it melt, and then
Yeah, you can separate. You can thicken the milk using that process. You're right. And if the milk hasn't been homogenized, it's easier to do that. But the milk you buy in the grocery store has been homogenized.
doesn't that mean like process?
Yeah, but the way that they process To homogenize, all they do is take the milk fat particles and break them up into smaller pieces. If you have milk right out of the cow and you put that in the refrigerator, a lot of the fat will rise to the top. And that's how you make butter. Take the milk fat and make butter out of it. Okay? Alright, since sugar likes water, it's called hydrophilic. Okay? Like Philadelphia is the city of brotherly love. Loving water is hydrophilic. Well, the city of brotherly love in Pennsylvania is named after another Philadelphia in the Bible. I know a lot of things. I know why Spartanburg's named Spartanburg.
Why? Is it from Sparta? The movie
Actually, it was given that name when this was sort of the wild backlands, and it was a Spartan country.
Why is it called the Hub City?
Because it was a railroad hub.
Oh, I thought it meant like
That's what I thought it
Man, we call it
Why is it called Sparkle City?
They came up with that name, didn't they? Somebody came up with it.
Because of a 1950s rock and roll group called the Sparkle Tones. Sparkle Tones. Okay. Now, we had on the Tuesday before we left, did I stop this? Yep, no, I'm recording. Okay, capture, stop capture.